right. Hello, everyone. Welcome to today's knowledge session, which is another special one. Uh, my name is Emeka, and I'm here with a bunch of people, some of whom you can see, some of whom you can't. I have Bolahan here. I have Fumi and Julian also working in the background. Um, and yeah, I'd like to introduce our special guests for today's session. As part of the Africa Deep Tech Challenge 2026, we are putting out these information sessions that explore, different aspects of this challenge, and hopefully will give you insights that will enable you tackle the problem. Um, we're here talking about the last mile of AI designing for real world constraints. And we have our guest speaker, Oji Udezue. Oji is a good friend, first of all, I'm proud to say. But he is also the general partner of Phalanx Ventures and the former chief product officer, Calendly and Typeform. I'm sure many, if not all of you, have used those products at some point. And he'll be sharing practical insights from building products used by millions that you can, leverage in putting out your submission for the challenge. So we're going to explore a number of areas like practical frameworks for identifying high impact problems that are worth solving, how to design products that move beyond demos into real world adoption. We'll be looking at emerging opportunities across the various challenge domains that you're probably working on and lessons from global innovation ecosystems. And we're also going to be getting a sneak peek into a very special initiative that Oji is working on that ties into this challenge. And I'm not going to steal the thunder there. I'll let him share that. But it is a very, very special opportunity for everyone. So this is a great session. I'm not going to waste more of your time. I'll hand off to Oji. Oji, please take it away.
Hi everyone, how's it going? My name is Oji Udezue, and everything Emeka said about me is lies. No, I'm joking. I'm joking. So, a little bit about me. I don't know where you're from in the world, but I'm Nigerian American, um, and I have had the fortune to work in big tech, high tech, I guess that's what we call it, for the last 25 years, building some amazing products. Mm, I went to school in Nigeria. I'll talk with you a little bit about that. And eventually, I found my way to Southern California and doing some masters in double E computer science. And then from there, I started working for Microsoft. I worked there for a decade. I did a lot of interesting things. Worked on products you know and love, Windows, Exchange, Internet Explorer, um, Windows Live. I spent a lot of time working on Mail. And at the end of that time, I was a little bored and I decided to get an MBA. So I got, instead of getting one, I got two. And after some experimentation, I did a startup. I went to work for a financial industry, working for Ray Dalio, who's works at Bridgewater, the biggest hedge fund in the world. And after that, I sort of failed at doing startups at the time. And then I started my B2B SaaS era. Very quickly worked at Atlassian, Calendly, um, Twitter, Typeform, over the last 10 years. So that's a little bit of my background. Um, and if you give me a second, I'll flash up a deck sort of encapsulating some of this stuff. Um, so the thing that I think I'm going to spend about, just to cover it, I'm going to spend about 20 minutes talking a little bit about me and my journey. And the reason I'm trying to do that is a lot of you have exactly my background. And the reason I talk about that sometimes with this kind of audience is I want you to understand what's possible for you. meaning that everything that I did, you can do 2 times, 3 times, or what it is. But I'll just start real quick by saying that I um, grew up in Nigeria. I'm a product of the system there, whether you consider it good or bad. Went to primary school, secondary school, and I ended up doing my undergrad at the Federal University of Technology, Owerri. This is important because some of you, I don't know where you are, what you've done, but this isn't like one of the big storied universities in Nigeria. At least it wasn't at the time. Um, and the thing was, I was a disappointed college attendee, right? And the reason I say disappointed is that I was, I think I got into MIT. I took the SATs and got into MIT at the time, but my parents couldn't afford it. Afford to send me. And so I was a very frustrated, a very frustrated student because I could imagine what life would have been if I could afford to have gone to Boston and started out my degree there. But I made the best of what it was at Futo. Um, I was very, very curious. Um, I pushed beyond what my teachers could teach me. I remember at the time when I wrote a thesis in my fourth year, engineering is 5 years. I wrote about things that my professor really couldn't even understand at the time, and he was very frustrated with me because it was a little above what the text I was reading could read. But all this is not to say that I'm good or anything. It's to say, you just have to have your own special commitment to changing the game. You have your own special commitment to pushing the frontier. So anyway, all this is to say, when I finished with my respectable 2-1, because I couldn't be bothered to get a first class as I was trying to learn what was beyond the school, I decided that I would make it to the United States to, in my frame of mind, to compete with the best in the world. And uh, that's what I shot for. So when I came out, I worked in industry, worked in uh, networking. Yeah, I don't know if you guys still know these companies, Telnet, iTeco, and all the time I was working on doing my GRE and getting ready for what I consider was the big picture. So eventually went to the embassy I got an admission to USC, went to the embassy and they rejected me. And at the time when they reject you from coming to the US to be a student, you have to wait 6 months. And so for 6 months I sat stewing. I remember it felt a little bit like the undergrad setting. And I tried to fix the problem that they pointed out. And in 6 months, they said I could go. And so I became a student and I went to USC and did master's and research in high-speed networks. But all this was me pushing very hard to find the future that I wanted for myself. And after that, I started working for Microsoft. So that's how those two things connect. And so that's my journey. If I think it feels like a journey that anyone could go to. By the way, can everyone see my slides? Yeah. So if you can see my slides, it's sort of chronicling the journey so far. And I'm sure some of you might have questions, but this is the high level of it for myself. Before I go into my next section, I want to see if there are any quick questions about that journey that show up. I might not answer them immediately, but I want to see if that sparked anything for people in the audience, since I can't see you. If you have any questions, put it in the comments. Okay? All right. I don't see any questions, so I'll just continue. Um, so in terms of talking about my journey, let me fill out the last few moments of my journey because they are very important. By the time it's 2020, 2021, I ended up Twitter. And at Twitter, I was the VP and product lead working on tweets, actual tweets. So my team owned, tweeting, it owned DMs, it owned all the picture, everything you could do consumer-wise, the thing that people could touch was led by my team at the time. We did weird things like um, we built the first creator interface in Twitter where creators could send sponsored tweets. We built crypto so you could, pay with crypto across Twitter or give creators, tip them Bitcoin or whatever that was. We're still playing with that whole ecosystem. So that was my team. And, it wasn't just tweeting. There was also a huge consumer side of a publisher side of Twitter where we work with the NFL, we work with HBO, and we put their content on Twitter and we'd monetize the content for them and we do a revenue share. So that's where I was. Now, Elon Musk walked in and decided to buy Twitter. And once he did that, I understood that I had to leave. I couldn't be part of Twitter if Elon was there. And part of the reason was while he came in, he spent almost a year with us before he bought it. And I saw the kind of person he was and the kinds of things he did. And I just didn't think that Twitter was a good place for me. Plus, if you do an MBA, you also learn that acquisitions are very terrible times to be at a company. Strategy freezes, they fire a lot of people. So I just wasn't going to spend my time watching how this concluded. And I left and I wanted to build Phalanx Ventures at the time. But as I left, GPT 3.0 came out. If anyone remembers GPT 3.0, just do a snap or do an emoji thing. GPT 3.0 was the first GPT that really, really did a lot of things, did autonomous things. It felt magical. And so when it came out, because I've seen multiple, paradigm shifts, I saw the PCs come to the desktop for real. I saw mobile take off in 2007. I was there for the social revolution, all the Twitters and the Facebooks. In fact, people don't know it. I have a patent for favorites. So every time some of your contacts are special to you and you can mark them, is a patent that I created. So the idea of favorites. And so I've seen all those things, location, social, mobile, cloud. And so when I saw 3.0 land, I knew immediately that this was a paradigm shift. And when paradigm shift is terrible to be an investor because everybody you're seeing for 2 years are building on the old paradigm because they started like even 4 years ago. And so I felt like if I started Phalanx Ventures that I would be saying no, no all the time because I knew the paradigm had shifted. And I didn't want to do that. I didn't want to spend the next 2 years saying no, 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 no all the time. And so what I did instead was I joined another company, Typeform. And the reason I did that was I wanted to learn about AI. I wanted to learn what it was, how to build with it, how to solve problems with it, not just stare at it and be, in front of a terminal typing. I wanted to solve business problems with it. So I became CPO of Typeform, and I was responsible for driving them straight at AI. People didn't even know sometimes what I was talking about and what I meant, but I knew what was going to happen. And so I turned the company into an native company. I started a labs company within it, Typeform Labs, and we started building AI native products versus old products with a little bit of AI in it. So we wanted to build something AI native. I created relationships with OpenAI. I spent a lot of time at OpenAI. I was on stage with Sam Altman at their first developer day. So I did all these things because I knew what was coming. I could see it. And so for the past 4 years, I have been sitting with knowledge and future knowledge that not everyone can see, just because I've spent 25 years in the industry. And what that means is that I could see what native AI was going to do, or at least I could see some of it. And one way to check is if you go to, I'm going to put you guys on something you should follow, but if you go to our Substack, this is Product Mind. I have a consulting group called Product Mind. You'll see all kinds of almost prophetic writing about about AI, basically. So I encourage all of you to go and subscribe. Um, and we still do like a podcast every week or so and write a lot about what's happening in AI. And what we write about it's not like fluff. It's not what you'll find on the internet. We like what's behind what's happening. And so I think you'll benefit from it. So this is the background that I have, and this is where I've come from. Now, the last thing before I switch to you thinking about ideation frameworks for the event that you have is I'm a speaker as well. If you look behind me, you'll see a book. It's called Building Rocket Ships. It's about how to build fast-growing companies. My partner and I wrote about it. It informs a lot of thinking that we've done. It informs community that we are building. So if you are, a builder, we build communities for builders. So as I go, I'll just show you some things. I'm not really preaching these things, but I'm giving you resources for people like you. So one of the things I saw as I traveled around the world speaking to businesses about artificial intelligence was that it became clear to me that Africa, in Africa, we are sort of fucked. And I know I'm swearing and some people don't like it, but what I saw was a world changing dramatically where all of human progress was going to go through artificial intelligence, right? Because if you think about what AI is at the core, AI is we're minting new minds for labor, for work. In the past, people have tried all kinds of things to solve labor. Um, the people who had capital tried to get people to work all the time, and then workers had to claw back rights like weekends and so on and so forth. Obviously, in 400 years ago, people tried slavery, right? People couldn't work and do sugar cane and tobacco and cotton, and so they bought black buddies who could work harder as they thought because we're superhuman, which is not true, in conditions like in the Caribbean and the south of this country to get more labor. With artificial intelligence, we've created, so labor is very important for the world. It's very important to make stuff for people who have capital to get richer and so on and so forth. If you make AI ultimately what it is new brains to do work. And if you can do that, in theory, an economy that produces the best new brains, the smartest and the most, should in theory do better than those who do not. Okay? And so I began to understand that if this is the soul of a new competition for our planet, that Africa wasn't going to do very well. We don't have the energy density per capita to produce, training or even inference. We have lots of voids in our infrastructure, like electricity. I mean, even as good as mobile is for us, there's still holes and differences between that and OECD. And so I understood that if this AI economy is going to create 115 trillion worth of wealth in the next 10 years, that 70% of it is going to not go to us. 70% will go to others. Now, what does it mean if you have $1 million and your neighbor has 1 trillion? Will you be a servant to them eventually? Even if they don't enslave you, it's very hard to own your future when there's such a disparity in resources. You will always work in their resource machine in order to maintain your standard of living. And so this is what I think is going to happen. We're going to be left out of the gains that come from artificial intelligence if it as is. And so I know I've been talking about, I'll get to the hard stuff in a second. But what this means is that for Africa to survive, can everyone see this thing on the screen? Right? For Africa to make it, we have to divert a lot more of these gains to us in order not to become a marginal continent. We really have to do that. And then I sat with that for some time. I sat with that for months and months and months. And what came to me is that the only way to solve this problem is if we make inference very cheap, if we make it cheaper than dirt. Meaning, every time you want to use AI, instead of paying $5 per million tokens, meaning $5, you want to pay 5 naira, which is, I mean, if you know the exchange rate, which is a cost difference of 1,500 to 1 reduction. That's what it implies. If we don't have that, if all the people in your village can't use AI, then we're going to be left behind. Now, how does this matter? We now launched the ADTF competition, and the whole point of it is to make AI matter at a constrained cost, right? Within a constrained cost of hardware, if that makes any sense. This is the same thing. This is why, to support this challenge, we're building the Africa AI Prize. The Africa AI Prize is designed to be the much bigger envelope. We want to drive $10 million towards solving this problem, towards making inference very cheap for Africa specifically. But if we do it for Africa, we'll probably be doing it for the world. How does this tie into the challenge? The challenge is a precursor. It's a way for you to get your feet wet on the problem. Those who succeed in the challenge will be fairly easily entered into the big X Prize to win a much larger prize if they solve the problem in the context of the X Prize. I'm working with the ADTF to make sure that there's continuity, that we can encourage this challenge and watch people how they succeed so that they can enter into the much bigger prize, if that makes any sense. So I encourage you all to sign up for this challenge. You take it very seriously because it'll be a bridge to the Africa AI X Prize, which will be announced in the fall. You're getting a preview of it. So what we've covered so far is my journey, my involvement in LLMs, and what I saw that makes me think, oh my God, we got to do something dramatic. If we don't do something dramatic, we will be behind. So everyone is tracking so far. All right, good. You should be doing snaps at this time. So let's switch over a little bit to, let's call it, uh, let's call it maybe like ideation frameworks. How do you solve a problem like this? Where did you get inspiration? Now, one of the things I didn't tell you was when I went to USC, I didn't have enough money, actually. I had enough money to pay for a year, and a master's is 2 years. But, I worked really hard. First semester, a professor who was working on networks, high-speed networks, and building protocols, he decided I could join his lab. And when I joined his lab, then they paid for my tuition and they gave me a little stipend. So I became a research assistant. And I remember the time we were working on sensor networks, networks for small devices. So the idea is that you take a bunch of sensors, low power sensors, there's a disaster, you scatter them, and they collect information about the disaster and they route. There's no central master, there's no router, none of that stuff. They just connect to their own internal network and they pass data along all the way to the edge of the network where a human or another device can pick up the data and go away. So this was called like self-healing sensor networks at the time. But as a Nigerian, this was all foreign to me. I had to learn a lot to even get up to speed. And I remember asking my professor, I said, hey, like, where do I get ideas from? And he told me a really surprising thing. He said uh, that, and I'll lead with this. So I didn't want to lead with this, but I'll lead with this. It's more like you focus and then you step away. So he said, read things like the New York Times, read fantasy. But there's something very, very important, which is when you concentrate, you got to step away to let your brain work on things. And what I learned later, especially when I went to business school, is that there's nothing new under the sun, nothing. Every problem we have, including this problem of costs, has an analogy somewhere in nature that already exists. This planet has been around for billions and billions of years. And even the person who invented the wheel, quote unquote, we talk about this, we put it in cartoons, all they probably saw was a tree branch fall down and roll. And then they copied nature to make a wheel. So the solutions to almost every problem you have, scientific, biological, it doesn't matter what it is already represented in nature somewhere. What you need to do is to discover it, think about it, and bring it into the domain that you're interested in. And actually, I'll tell you how to do that for artificial intelligence mentally. But first of all, let's go through a few things. One of the ways that I think hard and I used in starting the XPRIZE is what I call governing friction. See, obviously, Africa has lots of problems. You could talk about poverty. You could talk about, uh, you know, um, regulatory capture. You could talk about corruption. There's all kinds of problems. We have raw materials that people take advantage of us for, pay low prices, process it and sell it back to us. You can say whatever you want. Now, does the XPRIZE solve any of these problems? No, it doesn't. But here's how I came to what it is. If everyone else is increasing their productivity by 5x by employing AI, and we are increasing our productivity, by the way, 5x is a lot, that's 600% or 500%. If we increase ours by 100%, we still lose. We still don't make it because competition is always relative velocity, right? So you'll be doing a nice doubling of your productivity. If someone does 5x their productivity, they're still your boss, if that makes any sense. And so if all of human progress is going to go through this and go through artificial intelligence, then that problem is one of the most important problems to solve. It's the difference between not having cars and competing with a society that has a lot of cars that can get around very fast. It's not possible. And so this is what I call governing friction linchpin. Every time you look at a problem, you ask which of these things is the most important that if I solve will unlock the rest of opportunity for everybody. If we don't solve AI costs, every improvement we make to economies won't matter as much relative to other economies, period, over the next 10, 20 years. This is why I arrived at the XPRIZE as one of the key things to go do. So this is called governing friction, removing a linchpin that allows much more freedom for everyone that comes after you. And so it's the same thing. If you see a model constraint, whether it's memory, compression, you ask yourself, what's the most important thing to do? What's the most important thing to eliminate? And this gives you a lot of scope. I learned this at Microsoft. I learned this over the years in my own life. So that's sort of one of the first places I'll ask you to go to gain some inspiration. Look at the space you're in. Don't knock off things from the top of the pyramid, okay? Knock off things from the bottom. If you knock off things from the bottom, then the pyramid reshapes itself and new problems emerge. And you do it like serially, right? You do it serially so that you knock off the big problems. Let me tell you one more story about this. When I was at Calendly, people asked us all the time to do certain things. Customers don't have a lot of perspective. So one problem they told us all the time to solve was they wanted to be able to send the link, give them a way to send the Calendly link. If you use Calendly, you know that the link is the key thing. And so they wanted a way for us to just click a button and then we'll send the link. We refused to do that. You know why we refused to do that? We refused to do that because we knew a few things. One was that it wasn't a root problem. It wasn't a linchpin problem. See, if you send the link, then eventually someone will say send it via email, send it via WhatsApp. Someone will say send it via text. People have all their ways they want to send it. And so now you have to build features to do it properly. And it's a never-ending thing. We also knew that people knew how to copy a link. Copying is the most trivial thing, right-click, select, copy, that you can do in computer science, in user interface. And once you copy it, then you can put it wherever you want. And so we didn't want to be stuck building sharing channels when people could just copy. We also knew that the only reason to build that feature is intelligence, meaning that if we can send it, then we can tell whether it was received, whether it was clicked, and track all of those things. We didn't have a huge need for the intelligence at the time, so we didn't build it. This is a classic example of even if your customers ask for something, you have to understand what they're asking for and whether that will unlock more opportunity. This would not unlock more opportunity. Same thing at Twitter. We didn't build edit tweet for the longest time. We didn't build it because our best users, the way Twitter works is 5% of people drive most of the activity. Everyone else sort of follows them. And the top 5% were not going to be more if we could let them edit a tweet. We eventually built it. I built it later, but it wasn't the most important thing to build. It was a vanity feature. So look for the governing friction of any system you're in if you want to improve it and eliminate the governing friction. This is important. There is out there on the internet, there's something called 100 mental models. You can search for it. Some of them are different, but if you have never seen this 100 mental models, I encourage you to go find it and just read it through. These mental models are essentially from philosophy. They encapsulate a lot of things that people have learned over the last 2, 3, 4 centuries, maybe even longer, about how to think clearly. I really want you to go get it. I want to introduce you to it. It's a simple search away. And then the last thing that I will tell you is if you're going to solve, if you're part of this challenge and you picked agriculture or you picked a vertical to go work in, one of the things that you have to do is understand that vertical really, really well. It's either you've already spent your time in it, right? Or uh, you talk to people who've spent their time in it. You can't really solve a problem if you don't understand deeply what are the constraints. You can't even do O1 if you don't understand O3. So let me talk a little bit about O3. If you're in product, people have told you about customer discovery. But really, the art of customer discovery is entering the mind telepathically. I mean that figuratively, of the problem domain or the people who are experiencing the problem. And really, the way to do that is to go out and talk to people. The end of the story. Go out and talk to people who are experiencing this or who work in this domain. So I'll go one step further. When you talk to them, you don't ask them busybody questions. You're like, oh, here's my solution. Do you like it or not? No one cares. Those people don't care. Instead, what you do first is ask open-ended questions. You ask open-ended questions and let them tell you things that are important about it. What is the hardest problem to solve in this space? What is a day in the life of your work in this space? If you are very experienced, like synthesize what difficulties are. How would you even use AI in this space if you could? Those kinds of problems. And then the next phase actually is that teaches you the kinds of questions to ask. So the first phase is ask open-ended questions so you can learn the right questions to ask. You interview 10 people, 10 smart people, not just random people. You'll soon learn the questions. You take those questions and you ask another 10 of the same kind of people and see if those questions get you answers faster, better, in a more discriminating way. And once you get better answers, you know that these are the right questions, or you take some questions out and you edit the questions. You can now send the remaining questions to 100 people via survey, because now they're the right questions. People will answer them versus the stupid first questions you'd have assumed were the right questions. And all of a sudden you have actual data. Because if 100 people respond to you, now it's numeric. It's past the threshold of anecdote. You now have actual data, if that makes sense. So I could teach an hour on this, but I thought that these were 3 places for you to start in order to honing on this challenge and to do it really well. I hope that makes sense. I hope I'm getting snaps on this one. They already talked about this. Ahmed Helmi taught me about this. So let's talk a little bit about the challenge. let's turn the corner to the last third of this conversation. Uh, at the if you're gonna change the cost of AI inference, I hope everyone understands the difference between training and inference. Otherwise, why are you here? That was a poke at most of you. But there's a lot of places. I guess let me start with a story. You see, when I was at USC a long time ago, there was a department on neural networks. And those guys, people used to laugh at them because, neural networks were not producing results in artificial intelligence. Neural networks are as old as the 1950s, if not longer. The boys who were in, you know, the boys who were enjoying were the machine learning people, right? So we vetted machine learning as a stopgap because neural networks did not have the compute and the data to become real. It was only till 2017 when the boys at Google wrote the attention paper. By the way, if you're here and you haven't read the attention paper or seen it summarized, I would correct that very fast. There's a paper called Attention is All You Need, which contains a theory that is the launch of large language models. You don't have to be a scientist to read it. You can put it in Notebook LM for it to explain it to you, but you really need to see it. The long story short is it decided that the best way to actually make large language models happen is to use what they call an attention mechanism. I won't go into what it is, but it needs a lot of data and compute in order for it to work. And by 2017, 2018, 2019, we finally arrived at silicon. And because the internet could be crawled, because Google taught us it could be crawled, and the data to make it work, which is what gave rise to LLMs. But I will say this, and the reason I brought up USC, LLM research is still in its infancy. This is something that's important for you to understand. It's still very young. An LLM is essentially a very primitive human brain because it's modeled. That's why we call it neural networks. It's modeled after the neural pathways that people observed in the biological brain. LLMs are also childish. A frontier LLM is trained on, say, 1 trillion tokens, which really means 1 trillion words, maybe more. By the time a child is 6 years old, is when they have processed over 1 trillion tokens, 6 years old. Every moment you live, right, you are processing more and more tokens. By the time you're 20, right, because you've learned to learn, you've processed an order of magnitude more tokens. So in theory, if you think just do the rough correlation of token is intelligence, these LLMs are as intelligent as a child in how they are, even as amazing as they are, Fable 5 and so on and so forth. The other correlation to this is because we built it on a rough sense of the brain, we're not done yet, okay? The brain is billions of years of evolution. It's figured out efficiencies. Your brain runs on 5 watts of electricity, 5 watts. A data center runs on gigawatts of electricity, right? The NVIDIA B100 chip is not as efficient as your brain. Because what is intelligence? If I need like 10 gigawatts to do what the brain does, I'm certainly not efficient at all. What does this tell us? The science is in its infancy, right? The brain does a lot of tricks that LLMs cannot do yet. The brain dreams, which is a compression mechanism, and a memory mechanism. The brain can focus, like you can be in a room and focus on one thing and block out all the noise, which is also a compression mechanism. There are all these tricks that the brain has to process properly that LLMs don't have yet, which means that we can make LLMs cheaper, more precise, and exactly what we need in Africa, which is cheap inference. It's possible. It's in the future. So What will I say? I will say that there are a few places that people can look for efficiencies. I don't know all of it, but I'll tell you a few. One is I just established that there's headroom. There's headroom here. This is possible. It's, the XPRIZE says we compress it 100x in terms of price. I'm sure there's more to it than just 100x. So there's room. So where are the other places that we can look? We can look at model architecture. There's a lot of things that people have discovered in the last year. They now have models that are layers, right? And so if they have resources, they run all the layers. If they don't have resources, they take a layer and put it in the CPU and keep a core layer in the GPU. There's quantization, there's distillation, there's all kinds of things that people can do to make an LLM cheaper and more efficient. There's hardware, right? CUDA is the thing that sits, the software layer that sits on top of NVIDIA. A lot of the power of LLMs come from the CUDA when you use is from that software layer. What if that software layer gets better, right? Now, we learned a lot of things from processors. I don't know if people take processors for granted, but initially with, 286 and so everything was serial, like one instruction at a time. Then we figured out what was called superscalar architecture, where you could issue 5 instructions at a time, and the processor would look at all of them. For some of them, if they need something the other thing needs, it does a speculative execution. So it will say, if this path is true, I'm going to keep going. And if this path is true, I'm going to keep going. And whichever path is true, it discards the wrong path, and then the path of execution of truth, it merges with the rest of the thing. This is called superscalar execution. So there are all these things that we've learned from processors, not even the brain, that can be used to optimize inference. Have you ever thought why, as you're typing your chat thing, it's not looking at what you're typing and then processing it even before you hit enter? These are kinds of superscalar approaches that optimize inference. Of course, there's training efficiency. We're at the time where I don't know if you know this because I don't want you guys to be too scared, but the first few models were built on 6 GPUs. 6 GPUs, and I don't mean NVIDIA class GPUs. They're built on regular 470s, 570 GPUs. It's possible, there are model cookbooks out there. You can build your own model. Maybe I actually encourage some of you to do that because that's one way to start to get into the bottom of this. You can build your own, you can do a training run and create your own small model if you want to. There are efficient ways to do this, better ways in applied research. And of course, there's system design where you take a small bit of this improvement, a small bit of this improvement, a small bit of that improvement, and you chain them together, right? In order to get an ultimate set of improvements. And then actually, the other day, I ran into a Nigerian PhD in computer science who invented a way to compress a model by like 30, 40%. See, when you compress models and tokens, you need fewer GPUs, you need less memory, and you're bringing down the cost. So these are all different ways to do that. Imagine issuing a bunch of instructions, compressing them by 100, processing them, getting the other. You could absolutely increase the thing. So there are probably more lanes you can do in terms of thinking about a problem and compressing the problem. But these are some that I would suggest. The other thing is, I really want people to focus on uh, phones. Phones are widely distributed. Android devices are open. There's some Linux phones. When the XPRIZE kicks off, we're probably going to create an inventory of some of these things so that we can loan them out if possible. But if you can get a model to run on a phone that's very smart, Fable level, you're solving the problem quite a bit for most people in the world. One other trick I have is I created an agent to go look at research for me. Every morning, ChatGPT delivers the latest applied research news. It will say, hey, here I scanned all the research repositories, Axe, Eve, and so on and so forth. And here's research that applies to the problem you're working on. And what that gives me is that every morning I can see what's the latest. This challenge is not it's not a new research problem. People are already all over the world researching this across thousands of universities. It is finding approaches that people have discovered that you can use to solve this problem, this challenge. And so I recommend you set up a small agent, before people would do Google searches, search alerts. What if you go to ChatGPT and Claude and set up a small agent to sort of look at the research repositories and find research that matches the keywords around this challenge daily? It serves as your own sort of step away. It's like, oh, wow, I didn't think of this idea. I didn't think of that idea. And maybe you can use it to apply to the problem. So I think that's it. So I want to leave some time for Emeka to ask me questions. Um, I think that's it. We are at a juncture where Homo sapiens and our society is going to change because we have now added a synthetic human. This is just a framework. You've added a synthetic human to the labor pool, right? In prior paradigm shifts, we haven't done as much as this. This is huge. In prior paradigm shifts, we have sort of survived it. Africa has done okay, maybe, although I still think we're 5 to 20 years behind most modern economies. If this works, we will be behind a lot because we're not situated to build as many synthetic humans as other economies will, and that difference will mean a lot. It will mean 6% of 15 trillion in new productivity that everyone gets 74, 94%. This is horrible, horrible outcome. If we make inference really cheap, if we make it 5 naira per million tokens, or 2 shillings, Kenyan shillings per million token, or whatever that is, we get not to win, but we get to stay in the game, right? And staying in the game is important before one of you comes up with another initiative that will take us above the game. But that's not me. I want to make sure we stay in the game. So take this seriously. You're working on something that is existential. If you succeed, you're going to change the lives of 54 countries, maybe more around the world. You're going to change the lives of hundreds of millions of people. And so I take this seriously, and I'm encouraging you to take it seriously. And I know that one of you will succeed because, brilliance comes from the unexpected, not just the people who are well funded. And I'm rooting for you. So thank you very much.
Thank you for that, Oji.
Thanks so much. Thanks so much. And one thing I actually did not say before we started, before I handed off to Oji, is that Oji and this conversation around the Africa AI XPRIZE is actually the inspiration behind this challenge, right? And so, that it was the conversation and the thoughts from Oji that actually inspired us to create this Africa Deep Tech to design this year's edition of the Africa Deep Tech Challenge 2026 to align with the vision of the Africa AI X Prize as a way to make sure that folks like all of us who are at the grassroots tackling this problem have a fair shot at participating in this initiative. And so, we're going to go into the questions that you've put in the Q&A section, and we'll go through them as quickly as we can.
Sorry, before we start with
Yeah.
the first question, can I just chip in? So, Oji, that was a very, very great presentation, and thank you so much for that. In fact, when you were going through everything you were talking about, I was just like, yeah, amen, amen, amen. This is like pretty much everything that I've gone through myself in like the past maybe a couple of years. When you talked about your time through school and struggling, and also how you were able to get work, and even when you saw all the technology shifts, and this is common among people who are quite smart. You get to think in decades, you can see technologies, and you can see where they are leading. And I guess at some point you could see what all these things, and I'm sure a lot of people around the world have seen it. And it's good that Africa Deep Tech has given us this platform where we could all just come together and discuss the ideas, create this challenge, bring people together, and see how we can actually put our heads and tackle the problem. So thank you so much for that.
You're welcome, brother.
Indeed, indeed. Indeed. So yes, let's go to your questions. I'll take it from the top. So Abimbola is asking, what made you switch from being focused on engineering to being more of a product-focused business leader? And how was the transition for you?
It's really a simple answer. So I have a bachelor's in EECS, and I have a master's in EECS. But I found in practice that I wasn't the best developer, right? Thinking in code was not my biggest. I didn't ever think I would be the best, just as a coder, as a software engineer. But my own gifts throughout my life have been about leadership, have been about insight, have been about communication, have been about some emotional intelligence. And so by the time I finished my master's, my inventory of my own skills, the things that would make me the best in the world, which was always my goal, were more aligned to product. Because in product, you get to essentially invent the future. Like, this is a thing that makes us win in this company. And I can see it. Not only can I see it, I can organize and inspire people to see it. And I can galvanize them to work to build it, and to build it in a customer-centric way. I was one of the best at it. I still walk around thinking I am one of the best at it. So I just gravitated to where I could be one of the best. I think that was it. Now, I have training in software engineering, like with all these new tools that make it easier. Because before, to translate an idea into code, I'd have to wait months and work with a developer. But because I actually understand algorithms and I understand software engineering, especially doing it at a very high level, these tools have made me super lethal. So now I can translate ideas very quickly, just because I have the background and I have the right tools now. So I feel very productive at this time. If you, just as a quick plug, if you go to skills, we've started to build not just community for builders, but we started to build tools for builders, and tools that cut across not just code but business. Because if you go on GitHub, you see all kinds of tools for coders and memory and all these things. What we've done instead is build skills for builders that have business logic and business judgment encoded inside it. And that's one of the things I'm building for the ecosystem of people who follow me and follow our system. So and this sort of perfectly expresses why I'm not just a software developer, because tech companies are 3 layers. It's code/software, it's product, and it's business. And you don't have a tech company unless these 3 things mesh well. If you have only the code layer, that's not a tech company. It's required, but it's not sufficient. And so being able to think through all the layers is super important in order to succeed. And that's what I do. And that's what I figured I would do better than most people than just the first layer.
Awesome. Thanks so much. And yes, there were a number of questions asking if we will make the recording of this conversation available. The answer is yes. We always try to do so. So,
can I chip in, please, very briefly?
Yes.
So looking at what Oji is showing here, I do believe that to a large extent, a lot of different versions of this kind of system are going to spring up. In fact, they're already springing up. People are building systems where humans and AI agents can share context and connect to tools and accomplish different kinds of workflows. And one of the things that I've been thinking about is it worth it, or does it make sense if every single um, organization or every single person is trying to solve the same problems? What if there's possibility of creating different forms of open source technology, or even contributing to existing open source technologies that could provide like public infrastructure, right? That people that are building tools like this can actually leverage. So it's less duplicated efforts and there's more coordination. So I don't know if you know what I mean. So think about it like this,
Well,
right?
the problem with that is, people atomically come up with ideas and they don't talk to other people. So eventually the market wins. So whoever has the highest reputation version of these things, people gravitate to it. And that's the only way. Otherwise, you have to talk to everyone all the time, which is
No,
impossible.
no, no. No, of course, of course, of course. But regardless, though, I do believe that this kind of thing we're trying to do, we should look at a kind of ecosystem approach to it, right? Where it's not just about building one product. There's different kinds of technologies that need to come together. So, for example, we're talking about local AI. We need something like a kind of intelligent model routing, because not every model needs to do
I
the
mean, that
same.
that already that already exists.
Yeah, yeah.
And there are many solutions. I think
Mm-hmm.
the market will solve which is the best solution, right? Just
Yeah,
like
of course,
anything
of course,
else. Well, there are
of
many.
course.
If you go to openrouter.com, or
Yeah, no.
Databricks just launched something called Omnigent or whatever it is. So
Mm-hmm, mm-hmm.
the market needs this. Which is the best is what's being debated.
Yeah,
So
yeah, yeah,
I would
sure,
say there's a lot out there.
sure. All right, all right. Let's. Thank you for that.
Emeka, you're
You're
muted, so we
muted.
can't hear you.
Yeah, and I just dropped a lot of wisdom right there, but you missed it.
Try it
Um,
again. Try it again. We are here. We'll hear the wisdom and judge.
Oh man, so yeah, no, great conversation. So we have another question from Abimbola, and it says, "How did you build the intuition slash taste for people products ahead of others?"
Hmm. I don't know. I don't see. Look, I, product is a little mystical to people, but there are things that can be learned and things that cannot. It's just like not every basketballer can be LeBron or be Michael, but there's some pretty good basketballers, regardless of that. So some of it is just like your gift. Like my daughter she's not trained, she's 15, but she has a good design eye. Right? If I'm designing something, a book, anything physical, or I will ask her to look at it because she was born with an intuition, which is very strong, which is better than mine. So I ask her because I'm humble like that. So there's some of that. But I think the other thing is, and I think if the way things work is that we find patterns. Some people find patterns fast, some people find patterns slow, some people find patterns in a specific area very fast, and then other things that are obvious to people they don't find very fast. And so I would say that the thing you can learn is to talk to people who will use the thing in the problem space. If you talk to enough of them, you will start to develop a product sense about the space. That's the thing you can learn. You see, most people, most engineers, we don't talk to people. We just sort of say, this is a good idea. Seems good to me. And then we start to execute on it. Wrong. Because it's a very selfish, self-centered way of thinking. Instead, it should be, seems good to me, but I need to verify. And then it will take you go talk to people to see if your whatever is correct. One of the things, if you go to this thing that goes off of labs, we have an agent that will help you confirm if the thing your idea is any good, right? It's like it will say, is this problem even worth building? It's just a chat interface with evals and frameworks, product frameworks within it. I'm not plugging this, by the way, because right now it's free and you're costing me money if you use it. But the point is, the fastest way to get to intuition is to talk to people who are experiencing pain. And then the rest is maybe gifts, right? Your intuition that God gave you or whatever, or whoever gave you, if you don't believe in God. So that's what I would say.
All right. Thanks so much. Marvina is asking, when building or scaling an ecosystem, how do I balance the drive for compounding gains with the hidden risks of entropy as the system grows more complex?
Who is this PhD candidate? Oh boy, just put like a lot of things in here. Um,
I can read the question again.
no, I understand it. I was just wondering if everyone understands it. How do I balance the drive for compounding gains with the hidden risk of entropy? I don't really think that since you already know about compounding gains and entropy, I don't think those two things are necessarily in conflict. The idea of compounding gains is finding linchpins that you can stack. I already talked about linchpins and talked about the most critical problem in a space. Entropy is just the idea that things tend to disorder. So if you understand your compounding gains, you have to put them together in a way that is anti-entropy. Or you decide that you will do them serially so that you don't add them all together in a brittle way. So you do one so you understand all the way it behaves. And then once you understand the way it behaves, you layer on the other one so that you don't put two things together that behave unpredictably. We learned this I was there for Microsoft Vista. And the reason Vista failed was because we tried to do too many things at once. We did object-oriented data storage, object-oriented user experience, and one more thing, right? That became the core of Vista. And those things were all immature. When they came together, it was a complete disaster. So this perfectly illustrates what you're talking about. So I think what you got to do is identify linchpins. Usually executing on them well is compounding, right? An XPRIZE is compounding. Once we solve the costs, everyone goes to town, market women using it, and the economy grows very fast. That's a compounding thing. So use that and be careful in how you combine them, understand them before you combine them. I think that's the way to think about it. Go ahead. What else?
Awesome. We'll be moving it along now. So Marvina is also asking, in fast-moving environments, how do I determine when to use first principles to innovate from scratch versus leveraging inversion to simply avoid known failure points?
I don't understand what inversion means. So I think for me to answer this correctly, you have to define what that is because you're using frameworks that I'm not sure I understand precisely what you're talking about. But I will just say generally that you shouldn't really this is a question of speed. And what I've found is that speed is rarely the issue. Speed is rarely the issue. If you solve a problem comprehensively, really well, and then you bring the fruits of that approach to market, you're probably going to succeed because very few markets are winner take all. We just lie to ourselves that winner take all is the default. So even if someone else has come to market with something else, if yours is better, eventually you will win. If the difference is very significant, right? If the delta between their solution and your solution is 5x, you will eventually win, unless you sort of are terrible at marketing. So I would question the presumption of speed, and instead I would say solve problems comprehensively 3 to 5x better than other people, and you should still be okay. That speed thing is usually the mistake.
Mm. That's a deep one. Toby is asking if vector embedding can be of help in compressing, or like, what are your general thoughts on this?
We're finding that in practice, we're finding that vector systems are not very useful anymore. There are very few people talking about vector embeddings anymore because large language models are gotten so good that you can do a lot of productive stuff without vector embeddings. Because vector embeddings are just like fast, lossy RAG, for those who understand AI, on top of an LLM. And they're getting really good without needing that. So I don't see how vector embedding is an effective solution in this space. Now, I could be wrong. Maybe there's some other approach to vector embedding, but in general, I think that what the research is telling me and in practice is that the days of vector embedding as a key strategy versus a niche strategy are kind of over.
Yeah. Cool. So somebody was asking, I think they are new to the whole challenge. They just joined and they would like to know where to get more information. So I'll just put the link to the challenge in there, the Africa Deep Tech Challenge 2026. And if you go there, you get all the gist about the challenge, what it's about, how you can participate, how you can win, and all the exciting stuff. So we have a question from,
Probably to
uh,
help, Emeka,
sorry,
like
go on.
you can also go on our YouTube, the very first knowledge session, also answers some of the questions that you might have. Dropping the link in the chat as well. It will be very helpful for you.
Awesome. Thank you, Bolan. Yes, you'll get all the context you need from those links. An anonymous attendee is asking, he said, what would you say, uh, let's see, what would you say alternative non-model, maybe he's saying, let me frame the question the way I think I understand it. I think he's saying, what would you say about alternative non-model upgrades that we can
Yeah.
use to improve the model performance and quality?
The model is probably the biggest linchpin itself. That's why people spend a lot of time there. But the thing that you do is to trace the value chain of value delivery. So there's a model, well, there's training, right? Which creates the model. There's the model and it running, which is inference. There is the networking to get you access to the model and it responding back to you. There is the memory that the model needs to run, which is probably in the data center. There is how efficient it is with tokens, right? Models, the same model, same response, different efficiencies in token management. There's the harness itself, which is a little bit out of the thing. The harness can also affect the efficiency of the system. So there are all these things that chain together in order to give real value at the end of the end user. So if you're not going to do model, you have to improve something else in the pipeline. So that's what I would say. So trace the pipeline and find all the bottlenecks in the different areas that's non-model and improve those.
Okay, cool. Ugochukwu is asking, I am currently into local AI research, particularly interested in optimizations. But most of the time, I find myself limited by compute access to train or experiment with models. What can you advise me to do?
Buy more compute. Whatever. Don't eat dinner for a month and get more compute. No, look, if you are in this space, you're gonna need more compute than the average person because we're talking about the delivery to the average person. This is why, Model Labs buy a lot of GPUs. They need the horsepower. Think of yourself as a one-person AI research lab. Now, what you probably need, I think the ADTF can talk about access to compute and compute time that more than you have. And so they have partnerships that can give you that access if you apply for it and if you qualify. So I think that's a question that we'll throw back to ADTF.
Yeah, indeed. So if you're participating in this challenge, you can actually apply to be considered for, I believe it's up to 5 hours of compute from our partner UduTech. And so if you go to the challenge website that we shared, you find information on how to do that. So you go there, you fill in your application, and you'll be considered for up to 5 hours of compute that you can use to train your model for this challenge.
If I might also add something that might be beneficial, while our priority is obviously for the challenge, but a lot of the cloud providers also now have a tier for Gen AI. If you're doing things related to AI, you can apply to any of the cloud providers, Google Cloud, AWS. They have a very generous tier, provided you can justify what you need that compute for, and provided you have a very valid reason for what you're working on. And you should, I mean, sometimes you can qualify for as much as $3,000 worth of compute access.
Indeed. Thank you, Mola. And again, just for folks putting their questions in the chat, please use the Q&A feature. It makes sure that we will get to your question. So we have another question from Marvina. She's asking, when engineering phone-first AI solutions for mainstream African handsets, how do we balance the unit economics of cloud-based API costs against the technical constraints of running highly optimized lightweight models directly on lower spec on-device hardware?
I think those are two different tracks. I think the value chain around API served, and if you can see my screen, as far as the price is concerned, we have two tracks, local AI and API served. I think the API served is different. So I don't necessarily want to, I mean, in theory, if you have a really strong local AI model, you could host it on a data center and have it served by API. That would be the best. But the fact that data centers have specialized equipment would mean that you are sort of leaving some optimization on the table. So I think there's always going to be local AI and API served AI. And actually, one specific area of optimization that hasn't appeared yet is a bridge between API served and local served. So you can imagine the future, you will have on-device AI to do most things, right? And then when you need something more powerful, it will route to the cloud via API, come down with a response, and either give it to you or merge it with further processing on local on-device AI before you see it. That bridge hasn't happened yet. The research is still fairly early. A lot of people are working on it. But if you can think of that as part of the value chain of optimization, that would be amazing. That would be a good result. So I would say local AI is very good for Africa. But if you really want to change an economy, you have to have both, I think. So don't merge them. Keep them separate in your mind for a bit and then see what happens. Eventually we might, but I don't think it's obvious that's the first outcome.
Awesome. So yeah, we have another interesting question here, also from Marvina. So basically the question is asking, given the speed of how fast AI research is moving on a week by week basis, what architectural frameworks or design patterns will allow an emerging venture or small startup to, to be able to instantly integrate the latest efficiency breakthroughs without constantly breaking live production grade systems as it's scaling?
I don't think this is a new question. Imagine that you're running your business on 386s and then 586 comes out, processors. You have to ask yourself, well, how long can we run this thing on 386 without having a competitive disadvantage? And how do we migrate to 586s? And in what time frame? And it's the same thing. There are things that you can understand going into it, which is if you care about cost, you probably need some model routing and token accounting built on top of your system. You need to build abstraction layers so you can swap out the intelligence engine, whether it's Gemini or local or whatever. If you use Olama or use LM Studio, they now have clones of the OpenAI API or the Claude API so that they look exactly like the frontier models, so you can just swap them out. You can take out Sonnet and put in a local AI that has a nice interface that looks like Claude. And so that's what people do. And so if you do some of those basic things, you are going to you're going to be able to create some ability to move quickly. So one of the things that give me a second. One of the things that I guess I'm showing you guys, 1 second here. One of the things that we produced at Product Mind is every quarter we write like a AI dossier. This is part of my consulting group, write an AI dossier about these things for enterprises. And this is sort of an enterprise question. How do I make myself not so tightly coupled to all the daily stuff? And so this dossier, I'll share it with you guys. It's free. It's usually, we send it to executives, but it's a good read on how to think about the business problems in AI.
Amazing.
I'll just send it here.
These are the things you get when you stay locked to the Africa Deep Tech community. It's amazing. Thanks, Oji, for sharing that. Really generous.
I'll put it in the I'm gonna put it in the chat. I'm gonna put it in the chat. Yeah, Roy can get it.
Okay. Maybe I'll take this question from Toby. He said, you mentioned an example of using a local AI agent before searching. Is it okay to say combining deterministic approach in programming before passing it to AI is a way to also make inference cheaper in a sense?
That's a good question. There are software projects I have where I decide where inference is needed and only use it when it's needed. So, by the way, I hope everyone has a GitHub because I do. In fact, let me brag on my GitHub. Let's see, where's my contribution contribution grade? For those who don't know, this is what my contribution grade looks like now, and I'm not a developer, so this is me checking into GitHub.
I'm trying to be like you, Oji.
Sorry?
So I'm trying to be like you, Oji. Mine is about 1,000 plus.
Well, if you're trying to be like me, you better keep up. You go hard. But anyway, what I'm saying is there are projects I have for sure where I try to understand where inference is needed and do some code. But I don't think this is part of the inference pipeline. This is just good software engineering. Now, the generic idea of applying inference where it's needed in an inference pipeline is interesting. I just don't know. I can't predict how it will be useful right now.
Can I chip in a bit? Sorry.
No, before you chip in, I want to make an analogy.
Okay.
The analogies I have is always like, regular silicon chips, right? They are parts of silicon chips that are high throughput and basic, right? Like the memory manager, the scheduler. These are things that I use millions of times a second, and they are very dedicated chips, and they're not the expensive computation chips. And silicon people use those things to simplify, dedicated chips to simplify. They're simple, they do one thing before they go into the superscalar engine, which does a lot of things, encryption, instructions, So the idea of doing something that happens frequently and simply and creating a specific resource to do that that's low energy, high throughput, before you do the complicated thing is a well-established strategy. I just don't know how it applies to all this. Go ahead.
Okay, just to answer the question, because I could see the question, if it's okay to, I'm sure I got it. Where's the question again? If it's okay to combine deterministic processing with non-deterministic inference. And I think there's even a term for this. It's like neurosymbolic AI, which, if you think about it, right, some systems or some problems require deterministic algorithms, and some other problems, require or can actually make use of inference. So systems like Claude Code, for instance, are very neurosymbolic, right? Because they combine a model with, of course, scripts, CLI tools, and stuff like that. So that's basically just what I wanted to chip in. It's very okay to combine such systems. In fact, that is actually what the architecture should look like. Yeah.
Okay, so we'll go to the next question, I guess, which would be from Ugochukwu. And Ugochukwu is
All right, let me speed run some of these questions. I think we could go faster, so we can get everyone home faster. So here's what I would say. Let me try and get to this one. What are your thoughts on fine-tuning versus pre-training? Most models out there are biased to Westerners, so pre-training seems like the best option compared to fine-tuning to get the best performance. Why can't we build foundational models from scratch in Africa? Again, looking at the chain of value, I think we should, but I don't think this is important in the big scheme of things. I would love to see classifiers that are based in Igbo, Hausa, Yoruba, Swahili, and so on and so forth, that understand those languages more natively. So that people don't have to learn English in order to use AI. But beyond that, what's beyond just bragging rights? What are we doing? Like, why are we creating a whole model from scratch aside to say, oh, we've done it? So I think we should do it, but we should understand that the problem isn't making a model. The problem is making it smart. The problem is teaching it world models. The problem is keeping it up to date, right? And evolving fast. And the truth is, we can't do that in Africa very easily because we don't have the energy to power the huge amount of data center stuff to do that. We should have spent the last 20 years, growing energy per capita, but we didn't. All right. So, which is why the XPRIZE is focused on cost, is that we don't want to pay Silicon Valley retail. You have to understand, $5 per million tokens is subsidized. Like Fable came and it was like $20. So the price went this way. It was going down and it went back up. Okay. And that $20 is subsidized. If they could, they would charge you $1,000. By the time they sell this back to us, when they're tired of subsidizing it, we won't be able to use it. Even now, when I use Fable, only 5% of the world or even less have used Fable. Most people are using free ChatGPT, right? Which is super dumb. If the difference between typing in ChatGPT for like, $0 and Fable 5 is the distance between here and the moon in terms of model performance. So sure, you can make a model in Africa, but what you really want to know is that I can keep it at the frontier. That's the task. It's not to make it. People make models in their basements today. Computer science students. That's not the issue. So look, I understand African pride and everything, but in the end, I'm always about making change. And what I want is cheap models I don't care where they come from. Cheap models available to us to reason. If part of that is making your own, go for it. It's all good. All right. How do we validate our model response quality? ADTF can take this offline. They have a whole test suite they want to use that's open source and available on GitHub, and they can talk about that. I studied materials engineering. I want to transition into computer science. I'm considering taking a postgraduate diploma in computer science. For someone like me who wants to specialize in AI and machine learning, would you recommend this path? Yes, I would. I would absolutely recommend this path. Simple answer. Are solutions around offline inference using already existing open LLMs, but optimizing usage also accepted? Or does it have to be? Yeah, you can use other models for sure. You don't have to build your own. If you have special ways of optimizing them, go for it. Do you think we should build new hardware systems to run today's AI systems or adapt current model to existing hardware? I think if you I obsess about running AI on very low power CPU-like hardware, like the ESP32, which isn't very fast at all. I think ultimately, because the brain runs on 5 watts of electricity, I think that is the real solution. We need to run it on really cheap silicon. Now, that will mean that some of you will think about silicon, taping out silicon. The thing is, if you invented low-cost silicon path, that chip will become the hottest chip on the planet and you'll become a millionaire, just to be clear. So if you have new hardware systems that you think will work, sure, go for it. I think that's actually the strongest foundation for this stuff. And you shouldn't be afraid, because if you invent it, someone will make it and make you a lot of money. So most people will adapt AI to current hardware because making new silicon is very difficult. But yes, it's definitely like a thing. If you have the skills, it's definitely a thing to do. In the age of AI and all, do you still encourage continue learning the software engineering or learning the ML itself? Well, someone learning software, do you encourage use of AI? Yeah, look, software is going to become AI assisted 100%. If you don't know anything about the people who are being paid the highest in the world are people who understand AI and AI research. People are paying a lot of money for that. Generic software engineering is going the way of the dodo, right? If the artificial brain can code, then what people are paying you for is judgment, and they're paying you for the ability to correct the artificial intelligence. And if you don't have that intelligence to correct the artificial intelligence, then what am I paying you for? If that makes sense. So learning about artificial intelligence, learning how to make models, how to think around the problems, evals, all these things is definitely the name of the game. Anyone who can speak any language can code if they have a logical mind. That's how you should see it. And so a software developer has to be able to do more than that. Otherwise, they have no value. This is just big picture. There's still all kinds of value, clearly. Like in Nigeria, for example, because of the adoption rate, there's still going to be a lot of work for developers, but it will decline, if that makes sense. What are your thoughts on the little infra available in Africa? In Nigeria, for example, we have few server farms. Do you think this affects AI growth in Africa? 100%. It does, which is why we're doing this. We want to make it so that any model in the world, at least some models in the world, can be very cheap. And we know people who are doing infrastructure in Africa, but just not enough to make a difference. America has built like 300 new data centers. China has built, I don't know, hundreds or trying to build hundreds. In that time frame, we'll be able to build 10. And they can keep this up forever. So yeah, it helps. But this can be our solution, right? Because we'll be going too slow and it's a relative race. Which should Africa prioritize at this stage of AI development? Curated, contextualized, localized data sets, or compute optimization? Well, we don't control compute optimization at all. So I don't think we should prioritize what we don't control. So the other thing. Which should Africa prioritize at this stage of AI development? Curating, contextualized, and localized data sets. Sorry?
It's the same question. So skip. Yeah.
Oh, really? Oh, okay. All right, cool. The Africa AI Prize is part of this hackathon? No. It's a big brother of this hackathon. If you do well in this hackathon, you might be able to get entered into the XPRIZE. All right. Do you think multi-objective evolutionary optimization is a suitable approach for efficient transformer inference, where the goal is to find Pareto optimal? I don't understand this. So you're clearly, if you understand this, then you're probably ahead of me in what you understand about models, so I can't answer the question. So I don't know. Can you please share a bit of roadmap or list of resources to become proficient to contribute build for this challenge, especially having basic training, classical ML, The ADTF team can tell you more about this. They might be able to send you more resources. Will the neurosymbolic you mentioned be used in judging the solution submit? I don't know what neurosymbolic is. Wallahan, do you know what that is?
No, I mentioned it. I mentioned
Okay.
it. What I was
Yeah.
saying is that the reason why we talk neurosymbolic is that if you look at algorithms in general, um, there are some parts of it that are so when you say neurosymbolic, neuro means neural is like of course intelligence relating to the brain. Symbolic computing, which is what we've been doing for up until now, is just your discrete code that you write, existing systems that you integrate to. So generally speaking, the way of computing is, AI is going to merge with existing systems, and so you have neurosymbolic systems, and that is just Claude. I mentioned Claude, Claude Codex. These are neurosymbolic systems because part of their processing uses models, part of their processing uses actual code, deterministic logic, and so that's just the way the way of it now. So yeah, I hope I answered your question.
Well, I think the real question is whether
Where is it?
whether it will be used to judge judge the challenge.
Or if it will be used to judge the challenge. No, not particularly. We have everything about the challenge is there in the so neurosymbolic doesn't have to do with the challenge. I was just talking broadly that it's more like architecture paradigms and how to think about architecting these systems, right? But yeah, the challenge itself, all the details about the challenge are included in the links. Yeah.
Okay, thank you. And just to quickly answer some of the questions in there, Emmanuel, I'm not sure what resources would make you participate in this challenge right now. So you can join the Discord, you can ask some of those questions. And for those that have been complaining about not being able to join Discord or having issues, please, if you go on the DevPost site, you would see a link that says email the hackathon manager. Please just email with a screenshot of the error that you're experiencing, and someone would be able to help you out. The Discord is the platform that we've created to support all the questions that you might have. And if you join the channel, we can answer some of these questions in more detail, considering we are running against time at the moment. Okay, with that being said, Oji, do you have any last closing words, closing remarks, anything that you want to share?
Not really. I think I put it out on the field. So I wish everyone luck. I just want to tell you that this work is important. This challenge is important. Is important to everyone you know. Is important to you. So take it seriously, lean into it, and good luck. Some of you will make it to the XPRIZE, which is much more money to win. It's a good
Yeah.
thing.
Yes, yes, yes. Again, the link and everything that you need that happened during this session was recorded. It will be uploaded on YouTube. If you don't have access to the YouTube channel, the simplest way to get access to it is to go on africadeeptech.org, go to the footer, and all the relevant links regarding africadeeptech.org, you'll find it in that footer, including the YouTube link as well. So Gillian, do you have anything that you wanted to add? Looks
I
like it.
I just want to appreciate everyone who showed up here today. Thank you so much. You were a great audience, lovely questions. A great thank you to Oji as well, our guest. Thank you for the brilliant insights. Thank you for all the conversation. And also thank you to our chief convener here, Emeka, and everyone at Africa Deep Tech. So it's just very great conversations today. And best of luck to everyone as well, attempting the challenge. We are rooting for you, and we'll be watching and also supporting.
Okay. Thank you, everyone. Oji has dropped the link to the Africa AI XPRIZE in the chat again. There will be more info that will be shared as, towards later on. So keep it logged. And thank you, Oji. Everyone, enjoy the rest of your day.
Cheers.